Problem 6 asks us to find the set S prime. So let's write our set braces here. And S prime, what this is the complement of S. That's everything in the universe. Here's our universe that is not in S. So what we're going to write here is everything that's in U but not in S, right? What is outside of S? Here's our universe. So what's outside? Well, 1, right? What do you not see in here? 1, 2 and 3 are in there. 4 is in there. 5 is not, and 7 is not. So what is outside of S that's still in here? Looks like it's going to be a 1, a 5, and a 7. Make sense? 1, 5, and 7 are in the universe, but they're outside of S. And now 7 says, what is in S union T? Now this is like taking everything in S and everything in T and just dumping them together into one big set. So whatever's in here has to be in here or in here. So let's see, what have we got? It's got to be in at least one of the sets. So 2 is in both, 3 is in here, 4, 5 is in here, 6, and 7. Looks like everything's in there. 2, 3, 4, 5, 6, 7, except a 1, right? So I'm going to take everything here. So we're going to get a 2, 3, 4, 5, 6, and a 7. But no 1, so we'll even separate them by commas here. Now number 8, this is the intersection. Number 7 was the union. That means everything in here had to be in at least one set. Anything in here has to be in this one or this one. Now this is the intersection. Everything in here has to be in both. It has to be in this and this. So this is an or in 7. Has to be in here or in here. So if you pick any one of these, like the 5, is it in S or T? Well, the 5 is not in S, but it is in T. So the 5 is in at least one of these. Now in the intersection, whatever I put in here has to be in both of them. So let's just look through what numbers or elements are in both sets. Well, 2 is in both, so we'll write a 2. And then what else? What about a 3? Well, the 3 is in S, but not in T, so it's not in both. 4 is in both, so we'll write a 4. Then, what about the 6? The 6 is in S, but it's not in T. What about the 5? The 5 is in T, but not in S. The 7 is in T, but not in S. So the only numbers that are in both S and T are the 2 and the 4. So we're going to write that as our set intersection. And in number 9, we are asked to get this intersection. So we're looking for the elements that are in both of these sets. So what are the numbers that are outside of S and at the same time in T? So look what we've done here. Here's outside of S, right? We already have that set. What's outside of S? 1, 5, and 7. And what is T? So you know what? Let's write this out. So if I write it out, here's what's outside of S. 1, 5, and 7. I want to intersect that with T, right? And T is right up here. 2, 4, 5, 7. 2, 4, 5, 7. So what's in both of these? Well, let's see. The 5 is here and here. The 7 is here and here. So the 5 and the 7 are the only elements that are in both of those sets. So we're going to say that this is now, I'll just write it up here. This is 5 and 7.